We've all been there, rushing to school in the morning, chugging coffee, and running over the day's activities in your head. Most of us don't notice much else about our morning commute. But what if you want to know more, like how fast you were at any particular moment, or even what your acceleration was then? Well, that's where the math comes in.
Hi, I'm Taylor Melton, and today I'll be teaching you differentiation.
Now, what's differentiation? It's the mathematical process of finding the derivative. And the derivative is the rate of change of a function in respect to a specific variable. Now, let's clear this up with some graphs. Let's look at a basic curve. Pretty simple. When we're trying to find the rate of change for this curve, there are two lines we focus on, the secant and the tangent. The secant line crosses the graph at 2 points and measures average rate of change over that specific interval. So with this, you could figure out that your average velocity or speed on your drive was 35 miles per hour. The tangent line only crosses the graph once and shows instantaneous rate of change. This is what we want. This is how you find out that 7 minutes into your drive, your speed was actually 40 miles per hour. So how does the tangent line relate to differentiation? Let's look at the two lines again. On this graph, we'll call this point x and this point x plus the change in x, since this is only the original point plus the change. When the change in x approaches 0, the secant line gets closer and closer to the tangent line, since when the change in x is 0, the secant will actually only cross at x, making it a tangent line. This is the goal of finding the derivative. We are finding the instantaneous rate of change for the function as the change in x approaches 0. The easiest way to find the derivative is the power rule, which states that if your function is a constant, times x to the b value, then the derivative equals b times a times x to the b minus 1 value. It's really just like a fun puzzle. So if you have 2x plus 3 as your function, your derivative is actually just 2, since the derivative of a constant is 0, and you get 2 using the power rule. Now, why does this matter? Let's look at your drive to school. Let's say it takes exactly 10 minutes for you to drive there, and this function models the distance traveled in meters on that 10-minute journey. Now the derivative, or rate of change, is going to be your velocity, since velocity is just how fast you change distance over a certain period of time. Let's say the equation for this function is x squared minus x, which just says how far you are from home at any time. What you want to do is find your velocity, or speed, using the derivative. Using the power rule, we can find that the derivative of this equation is 2x minus 1. Then you can plug in any x values to find your velocity, or instantaneous rate of change at that time. So at 6 minutes, your speed is 11 meters per minute. If you take a second derivative, then you can find acceleration, or the change in your velocity. For this equation, we can see that your acceleration is always equal to 2, meaning that you are constantly accelerating at that rate the whole drive. Better leave earlier for school next time.
Differential equations are a huge part of mathematics and important to understanding a lot of things in the real world. Thanks for coming on this journey with me. I'll secant you later.